Tonight's homework assignment comes from the puzzle page that looks like this. It says, which Arctic animals love math? So on these problems, what we're going to do is to solve the equation or inequality, and then we are going to cross out the letter next to the graph of the solution for that problem. What you'll be left with is the answer to the question at the top. Okay, today we started talking about absolute value equations and absolute value inequalities. The very first thing that we said we need to do on any of these types of problems is to isolate the expression inside the absolute value bars. Okay, what we mean is this. If you saw something to this effect, 3 times the absolute value of x minus 2 equals 9. Well, on the left-hand side of this equation, the expression inside the absolute value bars has not been isolated because we have it being multiplied by 3 on the outside of the bars. So our first step would be to divide the left by 3 and divide the right by 3. Alright, well, we don't have that in numbers 1 or 2. On numbers 1 or 2, all we see is on the left-hand side the absolute value of x plus 5. So there's nothing on the outside. So our first step then isn't necessarily to isolate it. It's already isolated. What this tells us, though, is that the expression inside the absolute value bars is equal to 12, or the absolute value of it is equal to 12. Well, that means that x plus 5 could equal 12, or it means that x plus 5 could equal negative 12. Because if this expression equals negative 12, then when we take the absolute value of negative 12, we get positive 12. So typically when we're looking at absolute value equations or inequalities, we have 2 solutions or 2 equations or inequalities that we need to set up. Once we get these equations set up, it's just like solving any other equation. Minus 5 on the left, minus 5 on the right. The 5's cancel, and we get x equals 12 minus 5 is 7. So one solution to that equation is 7, because 7 plus 5 gives us 12, so the absolute value of 12 is 12. So we know that that works out. Same thing on this next equation. We have x plus 5, so I need to subtract 5 from the left, subtract 5 from the right. 5 minus 5 cancels, so we end up with x equals negative 17. Well, if we put negative 17 into our absolute value equation, negative 17 plus 5 gives us negative 12. But the absolute value of negative 12 is still positive 12. So negative 17 works also. We do need to put that on a number line, just graph the solution. Since we have an equation which just says x equals 7 and x equals negative 17, we don't need to shade in one direction or another. So don't just assume that that's going to be the case. All we're going to do is to label the 2 numbers that we've got for that solution. We have x equals 7, x equals negative 17. So I'm going to put the lesser of those 2 on the left, negative 17, and 7 on the right. At that point, I will just put a dot on negative 17 and put a dot on 7, because that is the solution set of that equation. So for that problem, we see that the graph up here matches that, negative 17 and 7. Well, for number 2, we need to do the same thing. It tells us that the absolute value of 2n minus 7 is equal to 3. That means that this expression really can equal 3, or it can equal negative 3. So we'll set up 2 equations on number 2 also. 2n minus 7 can equal 3, or we just said that 2n minus 7 can equal negative 3. So when we solve for n, on the left-hand equation, we'll add 7 to the left, add 7 to the right. The 7's cancel, and we end up with 2n equals 10. And then we'll divide the left by 2 and divide the right by 2. And when we've done that, we get n equals 5. Well, let's check to make sure that makes sense. 2 times 5 is 10. 10 minus 7 is 3. The absolute value of 3 is positive 3. So that solution works out. Let's make sure that the second one does also, though. We need minus 7 on the left, so we need to add 7 to the left, add 7 to the right. 7's cancel, and we end up with 2n equals negative 3 plus 7 is positive 4. At that point, we'll divide the left by 2, divide the right by 2. The 2's cancel, and we end up with n equals 2. Well, let's check that. 2 times 2 is 4. 4 minus 7 is negative 3. So on the left side of the equation, we get the absolute value of negative 3. Well, if we simplify that, we do get 3. 3 equals 3, so we know that 2 is correct also. Let's put that on a graph, and it'll come out looking like this. Again, all we need to do is to plot those 2 points, 5 and 2. So I'm just going to do 2 little tick marks. I'll put the lesser of the 2 on the left-hand side, so 2 and 5. Since it's just an equation, n equals 5 and n equals 2, I will put a dot on 2 and a dot on 5. So the only time we're going to shade in one direction or another is if we are solving an inequality. So I'll look up here, find 2 and 5, it looks like P. Now, since some of the answer choices on your page are cut out by the holes, don't worry so much about getting the correct answer to the riddle or to the question at the top. Just be sure that you are showing your work for all of these problems on this page. Numbers 5 and 6, though, we do have something outside the absolute value bars on the left, so that'll be the first step that we need to take in solving this absolute value equation, is to divide the left by 8 and divide the right by 8 to get rid of the 8 that's on the outside. Well, the 8 divided by itself gives us 1, so all we're left with is the absolute value of k minus 15 on the left. On the right hand side, 24 divided by 8 gives us 3. Well, we just said, like on numbers 1 and 2, this expression, when we take the absolute value of it, has to equal 3. That really can mean that k minus 15 is equal to 3, or it can mean that k minus 15 is equal to negative 3. Well, if we simplify or solve those two equations, we need to do so by adding 15 to the left and to the right. If we subtract 15 and add 15, it's like they never happened. So on the left we get k. On the right hand side, 3 plus 15 gives us 18. So k equals 18. Well, let's check that. 18 minus 15 is 3. Absolute value of 3 is 3. 3 times 8 gives us 24. Let's do solve the right hand equation also. We'll add 15 to the left, add 15 to the right. The 15's cancel, and we get k equals 12. If we check our solution, 12 minus 15 is negative 3. Absolute value of negative 3 is positive 3. Positive 3 times 8 does give us 24 also. Let's put those solutions on a number line. Again, all we need to do is to plot 2 points since we have 2 solutions, and I'll put the lesser of the 2 on the left hand side. So 12 on the left, 18 on the right, and then we'll just put a dot on 12 and a dot on 18 to represent that solution. On number 6, we need to do the same thing. We have 7 times the absolute value of 4d plus 9. So since we have something outside the absolute value bars, the 7, our first step has to be to get rid of that. So I'll divide the right by 7. 7 divided by 7 cancels, so what we're left over with is the absolute value of 4d plus 9. On the right hand side, 77 divided by 7 is 11. So we'll set up 2 equations. We need to say 4d plus 9 equals 11, just as it appears there without the absolute value bars, and 4d plus 9 equals negative 11. Well, let's solve those 2 equations. These are 2-step equations, so we need to subtract 9 from the left, subtract 9 from the right. The 9's cancel, and what we end up with is 4d equals 2. Then we'll divide the left by 4, divide the right by 4. 4 divided by 4 gives us 1, so just d on the right hand side. 2 divided by 4 is 1/2. So you can write that as 1/2, or you can write it as 0.5. Well, let's continue to check our answers just to make sure that we've done these correctly. 4 times 1/2 is 2. 2 plus 9 gives us 11. The absolute value of 11 is 11. 11 times 7 gives us 77. So we know we did that one correctly. Alright, the second equation, I'll subtract 9 from the left, subtract 9 from the right, plus 9 minus 9. Basically, it's like they never happened. So 4d on the left hand side, negative 11 minus 9 is negative 20. And at that point, we'll divide the left by 4, divide the right by 4. The 4's cancel, just giving us d. And on the left hand side, or on the right hand side of the equation, negative 20 divided by 4 is negative 5. Let's check that answer. 4 times negative 5 is negative 20. Negative 20 plus 9 is negative 11. The absolute value of negative 11 is positive 11, and then positive 11 times 7 is 77. So both of our solutions work out. Let's put that on a number line as well. Again, all we need to do is to plot 2 points since we have 2 solutions. I'll put the lesser of the two on the left-hand side. This is 1/2. This is -5, so the negative will go on the left, -5 over here, 1/2 over here. Since it's an equation, it just says d equals 1/2 and d equals -5. We'll just put a dot. Looking at the bottom half of the page, we are looking at solving inequalities. This tells us that the value of x minus 3, when we take the absolute value of it, has to be greater than or equal to 10 units from 0 on the number line. So we said a quick and easy way of remembering how to form our graph on these types of equations is that if we have greater than or equal to or greater than, then we are going to shade outside. We are going to shade outside our 2 solutions. So I said if you see greater than, think we're going to shade a great distance. So we're going to shade to the outsides and put the arrows on the end to show that our solutions go forever in 2 directions. So we still need to set up 2 inequalities just like we set up 2 equations on the last problems. The first inequality is just going to be x minus 3 is greater than or equal to 10, exactly as it appears in the original inequality without the absolute value bars. But the second one, just like on the equations, we need to change it from positive 10 to negative 10, and instead of greater than or equal to, we're going to do less than or equal to. These are one-step inequalities to solve. Our first and only step is to add 3 to the left and add 3 to the right. Minus 3 plus 3 cancel, so on the left we get x. On the right hand side we have 13, so x is greater than or equal to 13. On the right hand inequality we still need to add 3 to the left, add 3 to the right. The 3's cancel, so on the left we have x. On the right hand side, negative 10 plus 3 gives us negative 7, so x is less than or equal to negative 7. So this is really an OR inequality, which we'll talk more about tomorrow, but we'll put those two, just like on the equation graphs, we're going to put those two on the number line, 13 and negative 7. We know negative 7 is going to go on the left and 13 is going to go on the right. We will plot points on there, and those depend on what type of sign we have here in this case. These are greater than or equal to and less than or equal to, so we're going to have a shaded in or filled in dot because negative 7 and 13 are included in that set of numbers. So we're going to, we said we're going, since we have greater than or equal to, we're going to shade outside those dots. So it's going to look like this on the right hand part of that graph and like this on the left hand part of that graph. So we want to shade everything that's either less than negative 7 or equal to negative 7 or greater than 13 or equal to 13. So our graph would look like that. On number 10 we need to do the same thing. We have greater than or equal to, so again, just like on the last one, we know we're going to shade outside. If we see less than or equal to, then we're going to shade between our 2 solutions. That's only after the inequality has been solved for, or after the expression inside the absolute value bars has been isolated. So if there is a negative 3 out here, then we would need to get that by itself first, get the expression inside the order, inside the absolute value bars by itself first before we determine if we're going to shade outside or shade between. So we'll set up 2 inequalities. We'll say 2x plus 5 is greater than or equal to 11. We have to say 2x plus 5. Again, we need to change that 11 to a negative 11, and since we had greater than or equal to, we'll change it to less than or equal to. So we're changing the sign of the number on the right hand side, and we're changing the direction of the inequality symbol. So we'll solve these 2 equations or inequalities by subtracting 5 from the left and subtracting 5 from the right. Plus 5 minus 5 cancels. So we have 2x on the left. On the right hand side, 11 minus 5 gives us 6. And then we'll divide the left by 2 and divide the right by 2. The 2's give us 1 when we divide, so x, and on the right hand side, 6 divided by 2 is 3. Since we divided by a positive, our number or our sign just stays pointing in that same direction. X is greater than or equal to 3, and then we'll subtract 5 from the left, subtract 5 from the right. The 5's cancel, and we end up with 2x is less than or equal to negative 16. We'll divide the left by 2 and divide the right by 2. The 2's cancel, and we end up with x is less than or equal to negative 8. At this point, we have our two solutions. We're going to put that on a number line. Again, since we had less or greater than or equal to in our solution, or in our original inequality, then we know that when we form our graph, we are going to shade to the outsides of our two numbers that we plot. We have 3 and negative 8. We know that negative 8 is less than 3, so we'll put that on the left-hand side. These are greater than or equal to and less than or equal to symbols, so that means that our points on our graph are included in that set of numbers, so we will put closed dots. Again, if it has a line underneath, that tells us that we're going to put closed dots. And we want to do everything that's greater or a greater distance from 0 on the number line than these two numbers, so we're going to shade to the left of negative 8, and we're going to shade to the right of negative 3. Again, the way I remember it is if you have greater than, you're going to shade a great distance. So we're going to put those arrows on the end that tells us that they're going to go in both directions forever. So that's numbers 9 and 10. Okay, looking at number 13, we do need to isolate the variable first on number 13, or isolate the expression inside the absolute value first, which means I need to get rid of the plus 3. So I'll subtract 3 from the left, subtract 3 from the right. Plus 3 minus 3 gives us 0. So on the left-hand side, we end up with the absolute value of 8p plus 1. On the right-hand side, we end up with 9. We will form two equations. We have 8p plus 1 equals 9, or we can say 8p plus 1 equals negative 9. We'll solve those two equations by subtracting one from the left and one from the right. The ones cancel, which just give us 8p equals 8. We'll divide the left by 8 and divide the right by 8. 8 divided by 8 gives us 1, so we get p equals 8 divided by 8 is 1. If we put that back in, 8 times 1 is 1. 8 times 1 is 8. 8 plus 1 is 9. The absolute value of 9 is 9. 9 plus 3 does give us 12. So then let's solve this equation. We'll subtract 1 from the left, subtract 1 from the right. 1 minus 1 cancels, and we end up with 8p equals negative 10. Divide the left by 8 and divide the right by 8. The 8's cancel, and we get p equals negative 10 over 8. I'll reduce that by bringing the negative sign out in front and making it negative 5/4. So when we put that back in, well, 8 times negative 5/4, that's going to give us negative 10 plus 1 is negative 9. The absolute value of negative 9 is 9. 9 plus 3 is 12. On the right hand side we have 12, so we know that both of these work out. Put your two solutions on a number line. Well, we know that this negative is less than the positive, so on the left hand side I'm going to plot negative 5/4. On the right hand side I'll plot 1. Again, since this is just an equation, we're just going to put dots on those two solutions, negative 5/4 and 1. And our final problem that will work is number 14. On number 14, our absolute value expression has not been isolated because we see a 4 on the outside. So our first step is to divide the left by 4 and divide the right by 4. 4 divided by 4 cancels, so we end up with the absolute value of 9 minus 3b equals 9. We'll set up two inequalities, or two equations that look like this. 9 minus 3b equals 9, and 9 minus 3b equals negative 9. Alright, at that point we just need to solve those two equations, and those will give us our two solutions to this absolute value equation. Our first step is to subtract 9 from the left and subtract 9 from the right. When that happens, on the left hand side we get negative 3b. On the right hand side, 9 minus 9 gives us 0 also. So when we divide the left by 3 and the right by 3, On the left, we just get b. On the right-hand side, 0 divided by negative 3 is just 0. Well, let's put that back in and make sure that it makes sense. 3 times 0 is 0. 9 minus 0 is 9. Absolute value of 9 is 9. 9 times 4 gives us 36. So then let's solve this one. Minus 9 on the left, minus 9 on the right. The 9's cancel on the left, leaving us with negative 3b. On the right-hand side, negative 9 minus 9 gives us negative 18. If I divide the left by negative 3 and divide the right by negative 3, we end up with b equals positive 6. Well, let's put that back in. 3 times 6 is 18. 9 minus 18 is negative 9. The absolute value of negative 9 is positive 9. Positive 9 times 4 gives us 36. So we've checked both of our solutions and know that those are right. Since this is just an equation, when we form our graph, all we need to do is to plot the 2 points that we came up with, 0 and 6, and then put dots on 0 and 6. We don't need to shade in one direction or another because all we have is 2 solutions, 0 and 6.